A cylinder has gas at 25 degrees centigrade and the pressure is 2 times 10 to the 5th Pascal. The volume of the cylinder is 4 liters. A, what is the number of moles? N. And B, if the volume triples and the pressure falls to 1 times 10 to the 5th Pascal, what is the temperature? Okay, so A, using the ideal gas law, PV is equal to nRT, and solving for N, the number of moles, N is equal to PV over RT, which is 2 times 10 to the 5th Pascal times 5 liters. Let's make this 5 liters instead of 4 liters. 5 liters instead of 4 liters. 5 times 10 to the 3 cubic centimeters. 1,000 cubic centimeters is 1 liter, so 5 liters is 5,000 cubic centimeters. And then converting that to cubic meters, 1 cubic meter is 10 to the 6th cubic centimeters, and then divide by RT. Okay, so that's 8.31 joules per Kelvin mole, and 25C translates to 298 Kelvin. And that works out to be roughly 0.4 mole. Okay, B. We're tripling volume and pressure is falling to 1 times 10 to the 5th. And since N remains constant, PV over RT is going to remain constant. So basically I can set P1 V1 over RT1 equals P2 V2 over RT2. You can see that the R's cancel there. And we want to solve for the final temperature. And so if we do this algebraically first, T2 is going to be equal to T1 times P2 V2 over P1 V1. Okay, so that's going to be equal to 298 Kelvin. That was the initial temperature, times the ratio of the two pressures, 1 times 10 to the 5th Pascal, divided by the, this is the final temperature, initial temperature is 2 times 10 to the 5th Pascal, times the ratio of the two volumes. And so if the initial volume was 5 liters, the final volume is triples, 15 liters. Now notice how, since for pressure and for volume we can use any units we like because we're taking a ratio of the units and the units don't matter. Always remember, however, that temperature has to be in Kelvin. And so we can see that the pressure goes down by a factor of 2 and the volume goes up by a factor of 3. So we have a multiplier of 3/2, 3 over 2, 1.5 in other words, and 298 Kelvin times 1.5 gives a temperature of 447 Kelvin.